Hi guys, so I'm going to be going over the solutions for the problems that you guys had to do for homework 4. So I believe I assigned A through C for the first problem, so let's start with part A. Okay, so our first job is to find the integrating factor. So I of x, that is going to be e to the power of this part. Remember, our general form for the first order differential equation is y prime plus a of x, y equals to b of x. All right, so this is going to be integral of a of x, which comes down to -2 d of x. So this is e to the power of -2x. So our part 1 is done. Second part is we have to multiply this value to the both sides of our equation. So that's going to be y prime minus 2y equals 2 e to the power of -2x. I'm going to distribute this inside of the parentheses, so that gives us y prime minus 2 e to the power of -2x, y equals 2 e to the power of -2x. All right, so our third part is to integrate both sides. All right, so by doing that, our left-hand side is e to the power of 2x times y, and you can quickly check by using the chain rule. If you have to first differentiate the first part, which comes down to this, and also add that by differentiating the next part, the y, which gives us the first part. So this is going to give us -1/2 e to the power of -2x plus the constant. Our final part of finding our solution is dividing both sides by e to the power of -2x so that we can have the y by itself. All right, so if we do that, and this is gone, that's gone, and we would have c over e to the power of -2x, which is equivalent to e to the power of +2x. All right, so to write this clear, we have y equals to -1/2 plus c times e to the power of 2x, where c is any constant. All right, so let's go over B now. Okay, so we're still using the general form, and our integrating factor would be e to the power of +1, integral of +1 dx. So that's going to give us e to the power of x. Second step is that we have to multiply this to the both sides of our equation, so that'll give us e to the x y prime plus e to the x y equals 2 e to the x times e to the x. And this is the general, the basic exponential rule. If you have the same base, then you can add the exponents. So I can go ahead and write this as just 2x. After you have that, the next step is to integrate both sides. So the whole point, again, of doing this, utilizing the integrating factor, is that your left-hand side will always end up nicely with our integrating factor times y. And this is going to be 1/2 e to the power of 2x plus c. Okay, so let's see, our next part is to divide both sides by e to the power of x. So I'm going to do that, so that's canceled. And here I'm going to have e to the power of -x. And here I'm going to divide this by e to the power of x. Again, it's the exponential rule, so if you have the same base, now that it's divided, so the exponents will subtract. So it's the top exponent minus the bottom one, so you'll have y equals to 1/2 e to the power of x plus c times e to the power of negative x, where c is any constant. Okay, now let's go over part C. So part C's problem is y prime minus 2y equals 2x squared plus x. Just double check. Right. Okay. Alright, so let's start by finding our I of x again. So this is going to be e to the power of the integral of negative 2 dx, so that's e to the power of negative 2x. Alright, multiply this both sides, so we have e to the power of negative 2x, y prime minus 2y equals 2 e to the negative 2x, x squared plus x, and now we can take the integral of it both sides. So on our left-hand side, we're left with the integrating factor, which is e to the power of negative 2x times y. That's going to equal 2. Now this part, it seems like we have to use the integration by parts. So if you guys remember, integration by parts is uv minus integral of v times du. So for our case, I'm going to say that u is x squared plus x. So du is 2x plus 1, and dv is e to the power of negative 2x, and v is negative 1/2 e to the power of negative 2x. Okay, so let's utilize this formula that we have. So on our right-hand side, it's going to give us u times v, so that's negative 1/2 e plus negative 2x times x squared plus x minus the integral of v times du. So it's v times du, and I see that v has a negative, so I'm just going to pull out that negative and make it positive. We have half times negative e to the negative 2x times 2x plus 1. And I'm going to go ahead and just distribute that. So we have this times 2x plus 1/2 e to the power of negative 2x. And I'm going to go ahead and give this separately in the integral form as well. Alright, so I think this one, the integration of that is pretty simple. It's just going to be negative 1/4 e to the power of negative 4x. But this one, I think we have to use the integration by parts just one more time. Alright, but before we do that, I can go ahead and 1/2 and 2. That just becomes 1, so we can just get rid of that. Alright, so let me do the integration by parts once more for this part of the integration. So u is, for this, it's x, so du is 1. dv is e to the power of negative 2x, so v is negative 1/2 e to the power of negative 2x. Okay, so writing everything out again, we have 1/2 e to the power of negative 2x, x squared plus x, and it's u times v, so it's going to be, let's see, negative 1/2 x e to the power of negative 2x minus integral of v times 1, but again there is another negative, so I'm going to make that as a positive. So we have 1/2 e to the power of negative 2x dx. And don't forget to bring that down. We have, that's going to be negative 1/4 e to the power of negative 2x plus c. I have to write this out one more time. the integration of that part is going to give us negative 1/4 e to the power of negative 2x dx. Okay, and so this is my left-hand side, and all of this is my right-hand side. So I'm just going to go ahead and divide both sides by e to the power of negative 2x. Conveniently, that term exists on every term except the last r constant. So I'm just going to add that, attach that e to the power of positive 2x, and that's it. So we have just to clean it up a little bit, minus half of x, and negative 1/4 minus negative 1/4, that's negative 1/2. So I guess we can all bring this in together. Oh, and c e to the power of 2x. We can all bring them all because they share the same coefficient, so we can make it look nicer by putting everything into the parentheses and say this is going to go in just an x. So we already have an x in here, so it's going to be 2x plus 1 and our constant. So this is it. This is our answer of our differential equation where c is any constant.